numerical on simply supported. As you can see, it's with a point load. Okay, this is the simply supported beam, supported at point A and B, and 2 point loads, 3 kilonewton and 6 kilonewton at C and D respectively. So we have to draw the SFD, that is the shear force diagram, and another one is the BMD, that is the bending moment diagram. And please mind that for simply supported, all will be in the positive direction or the positive y-axis. As you can see, I have shown you the baseline where you have to draw above the baseline. Okay, this is the baseline I'm talking about. Okay, baseline, and for this is the baseline. So please be mindful of that. Okay, so before drawing, we have to find out the reaction, that is RA and RB, the reaction at A and B. To find it, we can take either A or B moment, bending moment, not a bending moment, just moment, either at A or B. So before finding this thing, let's find out your moment at point A. So what will be the, to find out the reaction, please be careful about it. So to find the moment at A, there is this reaction RB, which is 6 meters away. Let me put the distances first so that you will feel right. This thing is given as 2 meters, again 2 meters, again 2 meters. Okay. Okay, let me write this: 2 meters, 2 meters, and 2 meters. Okay. So total this RB, which is an upward force or upward reaction, is trying to move the beam into anti-clockwise direction. So this moment will be positive, and other two, that is the 3 kilonewton and 6 kilonewton, are downward forces, are trying to move the beam into the clockwise direction, as you can see. So we will take this as negative and this as positive. So we can directly write the positive moment equal to the negative moments, two negative moments, okay, to find the reactions. Okay, let me clear this. Okay, so going back there, let's find out RB into 6. There is this 3 kilonewton force into, which is 2 meters away, plus 6 into, there is 6 kilonewton force, which is 4 meters away. So it is 6 RB. Okay, it is 6 plus 24, which is nothing but 30. So RB 30 by 6 will give you 5, which means 5 kilonewton. If RB is 5 kilonewton, the two reaction is supporting, that is RA plus RB is supporting the 2 point loads, that is 3 kilonewton point load and the 6 kilonewton point load. Okay, you can write it as also RA plus RB. Just go into the diagram, you will see that the two reactions are supporting the 2 point loads. So upward forces equal to downward forces. Okay, simply if you have to say. So RA plus RB, you know now RB, which is 5 kilonewton. So 3 plus 6 is nothing but 9. Okay, so your RA is equal to 9 minus 5 is equal to 4 kilonewton. So what we can write it as RA is equal to 4 kilonewton. Okay, your RB is 5 kilonewton and RA is 4 kilonewton. Okay, so if your RA is 4 kilonewton, it means if you try to find out shear force, we will start from the left hand side of the shear force diagram. So it is 4 kilonewtons because RA is acting at the point A. Okay, at the point A it is acting, this RA. So let me write it first. You will get to know. Just a minute. Okay. Okay. So RA, we have to write shear force at A. Okay. Shear force at A is nothing but just whatever the RA is. Okay. That is the 4 kilonewton. Okay. So upward force, so we are taking it as positive force. You can put the plus sign also if you want. And at C, you can see that there is 3 kilonewton force downward, going downward. So upward minus downward, 4 minus 3 kilonewton is equal to 1 kilonewton. Okay. again at point D, how much you are left with? First it was 4, then it becomes 1. There is again another force, that is a downward force, that is 6 kilonewton. You are left with 1 kilonewton, then minus 6 kilonewton, it is 5 kilonewton. Okay, so at D it is minus 5 kilonewton. If you remember, at B it was 5 kilonewton. Okay, so what will happen at B? It will be minus 5 kilonewton because there are no other point load, and there is this 5 kilonewton RB. If you remember, we have find out RA and RB, which is 5 kilonewton force. So this is the minus 5, which is showing that you have to go. See, at B it was 5 kilonewton we got, right, RB, but now this sign is there, minus 5. So we have to go in the diagram, we have to go down the baseline, okay, below the baseline. Why I'm writing here? To let you understand the fact that RB we got 5, but it is showing that this minus 5 kilonewton. Why D and B are equal? Because between D and B there are no other loads or forces are there. So it is definitely minus 5. So it is showing after D point our shear force diagram will go in below the baseline. It is into the negative part. Okay. So let me draw the shear force diagram. Okay. Your shear force diagram goes like this. First, if you remember, it is 4 kilonewton, right? Okay. This 4 kilonewton. Then what happens? At C, it is 1 kilonewton, okay? Okay, let me write it. It is 1 kilonewton. Let me put this thing also. I'm darkening this part. Okay. So it is 4 kilonewton. Initially, it is 4 kilonewton. Okay. Then what happens? This small part is how much? This small part is 1 kilonewton. And next, after or at D, what happens? It is minus 5 kilonewtons. So you have to go down the baseline because after at D, the diagram actually goes into the negative part or the negative y-axis. If you take it as positive y and this is as negative y, okay? Okay, so minus 5, we have to go down the baseline. So 4 was this much and we will go this much straight. Okay. 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 Make a box. Okay. I'm just darkening the thing. So this one is your 5 kilonewton. It is below the baseline. Okay. So this is how you represent your shear force diagram for what you can say your basically supported with point load. So it was AB, it was CD. So in the same way you can mention as D dash, C dash, and A dash and B dash. Okay. So by measuring the total area covered by the graph, you can find out the total shear force acting on the simply supported beam AB. Okay, so going back, we have to find out now the bending moment. So what will be the bending moment at A? If you see, your bending moment at A will be what? You can say there is this RA and there is no distance for it. So it is what? So it goes like 0. Okay. So next is bending moment at B. Now if you see, sorry, the bending moment at C. After the A point, it is the C point. Okay. So bending moment at C, what it will be? It will be your force RA into 2. Okay, or 2 meter you can say. So it will be RA is 4 kilonewton if you can remember. So it is 4 into 2. It is 8 kilonewton meter. Please remember you are finding bending moment, so it is the unit has to be capital and small m Newton meter. Next it is bending moment at D. So if you see, the bending moment of D will be RA into 4. Okay, since it is a downward force, so there is no negative with RA. Then there is this 3 kilonewton force acting downward. So 3 into, it is 2 meter away from the point D. So 3 into 2, RA is 4 meter and it is 2 meter. This 3 kilonewtons. So RA is 4 into 4 minus 3 into 2. So it is 16 minus 6. So it is definitely 10 kilonewton meter. Okay. Okay, so next is MB. So if you now see it, your 4 kilonewton RA force, I'm writing the RA directly as 4, it is 6 meter away acting upward. Your 3 kilonewton force is 4 meter away from the point B because you're finding the moment at point B, minus your 6 kilonewton force which is 2 meter away from the point B. So if you solve it, it is 24 minus 12 minus 12. So it is again 0. Okay, your MB. So kindly see your MA and MB is 0. So we are pretty sure with one point that our bending moment at point A and B is 0. Okay, A and B is 0. So what we will do, and we have seen at point C and D it is positive, so it will go up the order. So we will draw 4 lines. See how I'm drawing it, like that. Then it has increased from C to D. Okay, we'll draw it. Okay, these are two separate lines, and then if you remember, you have to join this because it has come down to 0. Okay, so how we can name it? C dash D dash. Do remember it is also above the baseline because it is above the bending moment are positive. So this is how you are drawing the bending moment diagram BMD for center support. It's very easy. First find the reaction RARB that I have found out. Then find the shear forces at each point, draw the shear force diagram and bending moment at each point and draw the bending moment diagram. So here I end the video. Please do subscribe the channel, like and share the video. It will motivate me. Thank you so much. Till then, bye bye.